Okay. Good morning, everyone. I'm Aritra Ghosh, and I'm excited to present to you this session on AI-assisted observability and troubleshooting. With me, we have Pavneet and Neha. Both Pavneet is a PM, and Neha is a software engineering manager at Microsoft. Okay, let's get started. So this is the agenda for today. We'll start off with the overview of the AKS monitoring and troubleshooting stack. So the major challenges with monitoring, some of the components of the monitoring and troubleshooting stack. We'll have a full stack demo. We'll follow it up by some of the best practices in monitoring and troubleshooting. We also have a framework of how to think about it, and we'll wrap up with an exciting demo. We have a bunch of announcements and demos spread throughout, so stay tuned and definitely pay attention. Just a quick show of hands. How many of you have some kind of monitoring logging today on your clusters? Awesome. Cool. Like George alluded to earlier today, we all know in today's world we cannot afford downtimes, if not, and they're extremely costly. This is from the latest survey in 2022 from the Uptime Institute, where they found out that more than 60% of failures result in greater than 90,000 euros. And this is just the financial loss. There's additional losses from worker productivity, customer breaches, and other data and other obligations. So this is just a data point. Let's keep going. So these are some of the common challenges that we see when it comes to monitoring Kubernetes. This is one way to think about it, and they are the technical challenges, the operational and organizational challenges. I want to focus on a few aspects of this. The first one in terms of technical challenges, the large surface area. Now we know Kubernetes is complex and there's a lot of moving components, so it could be networking, it could be control plane, it could be storage. There is just a lot going on. It's almost impossible for one person to know it all. In terms of the operational challenges, I want to focus on alert fatigue and some of the other integration complexities. There could be lots of alerts firing all at the same time, and they could have the same cause. It's hard to figure out which of them are correlated. In terms of integration complexity, you're probably using more than 5 to 10 tools. In the organization challenges, one of the important ones to note is the cost management and attribution. You probably want to figure out how teams are using some of the resources, how you how you figure out how you can attribute those teams. We again have an exciting session on cost management later today, but I'll touch on some of those aspects today. Awesome. So we went through some of the challenges and about downtime. Now I want to focus on some of the benefits of effective Kubernetes monitoring strategy. Specifically, there's two things I want to call out. Some of it is probably obvious. One is improved performance. If you have a good Kubernetes monitoring strategy in place, this will actually lead to a better and improved performance. What this means is if you're able to understand how your resources are utilized, and if you have correct limits and others set up, you're actually able to improve on your performance and then deliver the outcomes customer outcomes that you're interested in. The second one is easier troubleshooting. Again, if you have the right signals, then you're able to easily correlate and figure out where the issues are. That's again very important for being able to monitor Kubernetes properly. Awesome. This is where we now come to the structured monitoring paradigm. And this is a 3-stage framework. Again, some of it is connected, but the 3 important stages here is the detect, diagnose, and remediate. Fairly self-explanatory. In terms of the detect, you probably want to figure out any issues that happen ahead of time. You do not want your customers to report them. That's the detect phase. And I'll talk about how it relates to how our stack is structured. The diagnosis is figuring out, now you know that an error has occurred, but where actually is the error and which part of the stack it is in. The last one is remediate, fairly self-explanatory. How do you fix that? And possibly how do you automate that so that it doesn't happen again, or if it does, how do you make sure that it's fixed by itself? Awesome. This is where I'd like to introduce the stack. First, let's go through the 4 pillars of observability. You might have seen it elsewhere. The first is the metrics, second, alerts, third, logs and events, and the last one, traces. In terms of metrics and alerts, this is where it fits into the detect phase. You want to figure out that something is wrong in the system, and you want alerts configured so that you are aware that something has happened. You want them to be as real-time as possible. Logs and events and traces, they are to make sure where in the system the error is. So you have, once you have, I'd like to think of events as a semi-structured log. So they help you in starting diagnosis and eventually figure out probably in trace where in the traces there is. And trace is a end-to-end workflow of something from the users coming to your system to how it propagates all through. Awesome. So now I'd like to introduce the first product or feature of the monitoring stack, which is Azure Managed Service for Prometheus. This is the replacement or the managed version of Prometheus. You are well familiar with Prometheus, I hope. So if you don't want to go through the hassle of managing it yourself and ensuring that it's working and actually scaling, you use the Azure Managed Service for Prometheus. It works very similar to a Prometheus. You have all the out-of-the-box scrape configurations, rules, and alerts. You're able to customize them as you want. And the best part of it is it comes with all of the default dashboards and out-of-the-box dashboards in Grafana. So you get all of the richness when you use Grafana along with this. You're also welcome to use your own Grafana instance, but that's just an option. That's pretty much it. So we touched on the metrics, and the second part is the alerts of the detect. This is Azure Monitor Alerts. You're able to set up alerts on metrics, on logs, on activity logs, and Prometheus metrics. I'll expand on some of this through some of the demos later, but essentially this is how you set up on any of the constructs that are available. It is beneficial to set up alerts on metrics. They're both cheap and easy to compute. But you can also insert some instances. It's not possible to configure them on metrics where you can use logs. Then there is something called action groups. You probably want to have some kind of automation to make sure that it flows to the right team. You're able to automate it with your internal systems. So you can use all kinds of notifications, run books, and there's a lot of other things you could do. I'm not sure if it's visible, but there is, that's how it looks in AKS cluster in portal. Awesome. So we went through the metrics and the alerts. The third is the diagnose phase where we have the logs. This is called Container Insights. Now, some of you might have used Container Insights, and I want to specifically point out that Container Insights previously also collected some metrics and can collect metrics, but today it's primarily a logging solution. So if you are looking to collect your container logs and cluster events, Container Insights is what you should be looking at. And we have recently, based on a lot of good feedback, now we have lots of different configuration options to optimize costs. So definitely take a look at if you're looking to filter by namespace, reduce the frequency of how you're collecting logs. That's a great place to be in, and the cost management session is also going to touch on some of this. And this complements Prometheus and Grafana for some of the other monitoring services. I want to point out another important point. So the Container Insights is focused on the container logs. If you're looking to collect control plane logs, which could be your API server, etcd, cluster autoscaler, you should be looking at diagnostic settings. It's called diagnostic settings, and you can choose which component logs you're looking to collect. Awesome. And so in the diagnose phase, we talked about Container Insights. The second part is Application Insights. This is the tracing solution. It's available across AKS and other Azure services, such as app services. You can monitor different languages, including .NET, Python. And there's also distributed tracing and a bunch of very cool features. Awesome. One of the important things we hear from customers is we have all these products. We want to know where things are stored, essentially either for exporting or to understand what is different. So here, it's important to see that Prometheus metrics are stored in a different storage as compared to the logs, and it's called an Azure Monitor Workspace. We have often been asked about what is the storage called and how it's different. Why it is also important to notice these metrics are a lot cheaper than how they were stored in Container Insights. So it's important to notice the distinction between them. In terms of Container Insights itself, the logs are stored in a log analytics workspace, and the one on the right side is how you can consume them. So it can be Metric Explorer, and you could use different kinds of alerts. You can also set up log alerts like I talked about before. The next important part in some of the challenges of Kubernetes monitoring, I talked about one, the technical challenge of one person not being able to understand the whole surface area. The second aspect is the cost attribution and also figuring out who is responsible or who should be looking at what. This is a rough idea of how it should be like at your specific organization. This is also available on some of the monitoring docs there. So the developer should be focusing on the application side of things. So they would probably be interested in application insights and the metrics for the apps themselves. And that could be stored in managed Prometheus or any kind, or a regular Prometheus as well. The platform engineers, DevOps, and SRE should be focused on the Kubernetes objects, managed cluster components, and cluster level components. So they're available across container insights, Prometheus, and also resource logs. Resource logs is what is enabled through diagnostic settings. And the last one, the network administrator or anyone related to network, they are probably interested in the network side of things. So we'll have, again, awesome demos later on network observability. They would probably be interested in the network side of things. Awesome. So we talked about all the different signals which can be collected. Now we want to look at how they are consumed. We primarily have two different places at which you can consume all these different signals. And the first one is Azure Managed Grafana. I talked about it a little bit earlier, but essentially this is a managed version of the open source Grafana. It saves you the hassle of having to run it, maintain it, etc. It has a lot of cool full stack observability dashboards, and all you need to do, all come with a single click configuration. You're able to also import some of the community dashboards and use them. It has the network monitoring dashboards. It has a lot of community-based Prometheus dashboards. Some of these things might not be very clear, but I'll show a demo later. Awesome, I think this is the demo. So here I'll go through, we discussed a lot about the stack and how it can be consumed. I'll go through a quick demo of how it looks like. I have a cluster called AUL Ignite, and we'll go through looking at it together. Awesome, so this is how the cluster looks on Portal. There's a monitoring table of context where you're able to look at some of the aggregate metrics for the cluster. These are platform metrics themselves. And there is a direct link to explore from Grafana here. So you can click on that to get to Grafana. Here, all of this is pre-configured. If you're looking to configure them, we have all the docs. And of course, you can reach out to one of us today or whenever if you want to, any help. So these are all the different dashboards that I was talking about. Now here we'll take for specific, let's start with the full stack dashboard. That's like the first place you want to jump into when you want to troubleshoot or look at a cluster. It starts with some of the events. It has the utilization, memory CPU. It has all the requests for the pods. Now, interestingly, here we're going to focus on the application insights or the application side of things. We can see that one of the GET calls has a high average latency. We probably want to figure out what's going wrong there. So you can click directly there to figure out what's going wrong. This redirects to a different dashboard. It has all the embedded context of the app itself. You can see that some of the things are, it has the count of the errors, it has the average, the max. All of this, again, comes pre-configured. You can also add to it by some of the custom tracing. Here, it turns out that one of the services, not sure if it's clear, it has an out-of-memory error, and you were able to get to this trace from that start where you saw the high average was there. It has all the span attributes if you want looking at like a specific user or earlier. So you have all that error directly in Grafana without having to move back to Portal or elsewhere. Awesome. Now we'll go back to Portal to look at a few other things. Let's see if there's anything else here. Awesome. So this is the Insights tab, which has, again, some of the things like I mentioned, Grafana and Portal are the two places to consume. It has some of the dashboards for clusters, nodes, controllers. You're able to look at the memory utilization, CPU utilization of different pods. We'll show one cool application or one cool use case here. You're able to look at some of the trends right in portal here. So here on the right side, it shows the live logs. If you want to look at logs as the pod logs as they're running, you're able to see that right away in portal. Awesome. That is pretty much it in terms of the full stack demo. Keep moving. Awesome. Now it's time for some announcements, and these are some of the general set of announcements. We'll have specific targeted announcements and demos through the rest of the session. The first one, something that you have been asking for a long time, control plane metrics are now available in Managed Prometheus. So for those of you looking to get some of the API server autoscaler metrics, they're available through, again, Managed Prometheus. You can choose the metrics you want if you're looking to get an idea of the control plane usage, and if you're overloading them, this is a good place to start with. The second one, we have expanded Azure Managed Prometheus, and it's available in 12 new regions. The complete list is there here, but we are constantly improving and expanding where we are, so definitely check this out. And if you're one of them who are looking to use it in one of these regions, definitely it's a good chance. This is a few things that we are working on currently and hoping to release soon. I'll also share a QR code where if you're looking, try it out and give us feedback. You should take a look. The first one is PromQL-based metrics explorer. So if you're like today, the primary place to consume some of the Prometheus metrics is in Grafana. You're still able to query it in portal, but it's not present. It's not available easily. So that's the first one. The second one is CRD support. For those of you who already have Prometheus and looking to just use it easily, we'll be having CRD support soon. And the last one, auto instrumentation. If you're looking to not having to actually change all of the code, you can use auto instrumentation where all of the traces appear directly without you having to change any of the code. If you're looking to try out any of these features, definitely check out and reach out to the team. We are looking for feedback. That's how we iterate quickly, and we are able to ship as soon as possible. We'll also have all the announcements, all the QR codes at the end of the session. So, awesome. So we started off with the challenges, we talked about the framework, and we talked about the whole monitoring stack. Now let's talk about the troubleshooting stack. A quick show of hands, how many of you have used the diagnose and solve in portal? Awesome. What about resource health? And specifically AKS. Awesome, good to see that. So this is a recommendation and something that we have seen sometimes customers struggle with. You have everything set up, but when things go wrong, do start with diagnose and solve. It's a one-stop shop for all of the general AKS issues. It does have in-depth insights specific to your cluster, your scenarios. So check it out, and it has links to relevant docs and a lot of question answer forums. We try to keep it updated with the latest set of issues that we see customers struggling with. That's why I also recommend it. We have a small demo. I'm not sure if it's visible again, but yeah, it's very simple to use. You just go and you choose the area of the error that you have, the area or the domain of the error you have, and it gives you very deep insights based on analysis of the cluster itself. The second one, resource health. We haven't seen as much adoption, but resource health has some extremely important critical insights on the cluster downtime, not cluster downtime, but components downtime. So if you're looking to get some of those insights and also automate them, they're available through APIs. You don't have to come to clusters. You can set up alerts on resource health itself. And this is not specific to AKS. If you have a fleet and inventory of different resources, you can use it across all those resources. Awesome. Now we will move to the next part of the session, which is some of the best practices We'll analyze this and talk about this in terms of the framework we talked about earlier, which is the detect, diagnose, and remediate. Let's get started. Do I have? Okay, before I get there. So in terms of the common challenges that we see in terms of detection, some things that customers ask us often is, what metrics should I be monitoring? What alert should I configure? And there is no easy answer. Having been in the space for some time now, we have seen all the different use cases, the common things that customers run into, and we have a set of metrics alerts that we recommend. So I'll talk through some of them right now. So first, in terms of some of the general prescriptions, configure recommended alerts. What are recommended alerts? I'll talk about it right on the next slide. If you have external dependencies, so outside AKS, if you have things that you're using, it's important that you have metrics on them so that you're able to see some of those downstream metrics when things go wrong. The third important one is set up SLO, SLI monitoring for your applications. Whenever in doubt whether to set up an alert on something on application versus some of the infra components, always steer towards setting those up for applications. You should be focused on the business outcomes and your application use cases. Only when things go wrong at the application level is when you should be looking critically at the entire stack. It is okay and fine to set up alerts for some of the other infrastructure components, but the most critical ones should always be on SLIs, SLOs, and application level metrics. The last one, something that we often hear, how do I monitor upgrades? How do I know my node pool image, the node pool upgrade has failed? There's two different ways that we offer today. The first one is called Event Grid, so you can automatically get notified whenever a node pool image has completed, failed, succeeded. And the second one is Azure Activity Logs. Again, you're able to set up alerts on them. So if the cluster upgrade failed for some reason, you're able to know that it happened and then act. Okay, let's now go to recommended alerts. First, I'm excited to announce that recommended alerts is now in public preview. What is recommended alerts? It's a set of alerts that we have seen for the most common use cases across Kubernetes and AKS. So like you can see, we have different themes of alerts themselves. So they could be based on either Prometheus metrics or platform metrics. In Prometheus, that could be based on cluster level, node level, pod level. And we will keep this updated based on what we see. A set of alerts are there right now for you to check out. Awesome. And you have the option to choose whichever you want to and also customize them. While we have this expansive list, some of them may or may not apply to you. You can choose them and you can choose the severity and you can customize a lot of stuff if you want to, but we have some of the out-of-the-box alerts that we think will be helpful. This is where I'm excited to showcase a demo. This is based on the detected early. So whatever I talked about recommended alerts is already in public preview. Now I'm going to talk about some things which are in works and we're looking to get feedback. So let me get started. Here we have one of the community Prometheus alert rules. Specifically here we have expression where we are looking at the container usage, and whenever it exceeds a certain threshold, we alert on them. So this is for the entire fleet across all the pods. Now, as you can imagine, the challenge with this is static. So sometimes there are things where every Friday you might see an uptick in the e-commerce usage, and then again it rolls down on Saturdays or the weekends. We are looking at a use case where we could possibly, what if I told you that we would configure the threshold for you and you don't have to worry about it at all? So I'll go through all of this and then see what we're looking for. So instead of a static threshold, if you could configure this as a dynamic threshold where we figure the threshold for you, so we don't define the threshold like I showed before. In the recommended alerts today, you have to define the threshold. And behind the scenes, this could be using some advanced anomaly detection frameworks to figure out whether this is seasonal or whether this is actually an anomaly. And so, like I said, it doesn't fire on some of the normal peaks, and it fires only on abnormal peaks. I'll show you how it looks like today and some of the improvements on the alerts timeline as well. So this is the alerts tab in AKS. You can see there's like 58 alerts which are fired. The cool thing about this is, this is the timeline view where you're actually able to visualize how things have occurred in the past when certain alerts are fired. You're able to sample and look at specific namespaces and choose how it appears to you, because you want that kind of configuration and that specificity to be able to use it. So here we can see that there's two different kinds of alerts. One is called the dynamic and other is the static. And one of them has only fired 5 times. It accounts for the seasonality. The static one has fired 267 times. When you click on the alert, you're able to look at some of the details of why it fired. Let me keep going. Awesome. Here we are looking to see on some of the enrichments. I think it's the same. Okay. The next feature, the first we talked about, the dynamic threshold. The second part of it is enrichments. Now, oftentimes when there is an alert, you want to have it enriched with some queries or some other additional data. This is critical for you to be able to diagnose what's wrong and take further investigation. So this showcases how we can add some of the information. In this specific case, let's say you want to look at what was the image that was used, what was the container memory usage or CPU usage at that given moment. So this is how you enrich it so that it not just gives out that the alert has fired, but some other additional info at that moment. This is how you configure enrichments, and I'll talk about. So that's the PromQL query. Awesome. So here, when you click on the alert itself, you can see that you will eventually see an enrichments tab where you're able to see whatever enrichments that you had configured. You're able to look at them directly so that you don't have to spend more time. In this case, you see that the version of the container that was deployed has changed. That may or may not have caused it to fire. And you get all of this very quickly without having to again run these commands manually. That's another cool, I'm sure if you missed it. So this, once you have the alert, there's an investigate button on the top right, and this is to help you investigate, and if we do all the heavy lifting of figuring out what the root cause could be. So once you click on the investigate tab, it has a bunch of info that we gathered through AI. And another cool aspect of it is sometimes there could be things in AKS affected by other resource. So you could choose some of the custom resources that could be associated with AKS. You're able to look at some of the resource health events right here and do a lot of the monitoring and troubleshooting right here. So if you already see, you've kind of merged the detect and diagnose together, so it's easier for you to be able to focus on your application, on your business outcomes. Awesome. Yeah, this is the same one. So all this being said, what do you need to do? All you need to do is choose the threshold type. Behind the scenes, we will do all of this for you. Specifically, I'll go into the next slide. So if you're looking to try the enrichments and dynamic thresholds, please give this a try. This is so that we can ship quicker again, and we are able to get some of the critical feedback for us to be able to ship. We are tentatively looking at Q2 of 2024. But please let us know what you think, and if you think it's firing too often or if it's doing how it's supposed to, it'll help us figure out. The other thing about enrichments which we want to see is, do you think we should be helping you with some of the enrichments, or do you think you want the control over what kind of enrichments you want to add to these alerts? Next, I'm excited to announce that Enhanced Actionable Insights is now in public preview. What is this? In Portal, now in most of the resources and workloads and otherwise, you're able to look at a lot of the monitoring pieces right there. You don't have to click and go to a different place. So for example, the CPU, the memory, and some of the metrics are available right where you are. For the workload itself, you're able to look at events, the CPU, and the memory usage right there. Awesome. Now we'll move to the diagnose part of things. In terms of being able to diagnose effectively, I mentioned this before, Kubernetes events are a super cool place to start off. They're structured and they have a good initial indication of where things could go wrong. If you're looking to get some sense of how your cluster autoscaler is doing, why it's scaled up, why it's not scaled down, etc., you should start with the cluster autoscaler status on the node pool views. We have a bunch of good insights on the node pool views for node saturation if you're looking to see why your CPU memory has spiked up. If you're looking to investigate deeper to figure out some transient errors or looking to think why there is disk throttling, Inspector Gadget and Periscope are two good tools if you want to do some of the deeper level analysis. And last but not the least, for control plane logs, we recommend you use the resource dedicated schema. This is similar to this is exactly the same as diagnostic settings, but it helps you reduce costs by switching to the basic logs and also improves performance on the queries. Awesome. Now I'm going to take you through one of the exciting, cool demos. George talked about it a little bit in one of the cool Copilot use cases. Let's see. Awesome. So here I have a cluster, and we are going to see how we can troubleshoot easily. And this is on the logs tab. Let's say I just want to start off with looking at the memory usage of containers. And if it's someone like me, unfortunately, I don't know KQL. Let's see if we can have a query which will write this query for me. Not that I just don't know KQL. I don't know which table has it. I don't know the schema of the table as well. So here is a write a KQL query to identify pods with high memory usage. And it comes back with that entire query with the table of what we are supposed to analyze. And here you can see you have all, and you're able to just click execute, and it's able to run it here. So you see all the memory usage and of all of the containers. If you saw, the next query was showing error logs, and it was able to generate error logs from the last day, figure out the table, and figure out the columns. We will see that there's a lot of log entries here, log errors here. It's hard to understand all of that, so we probably want to chart it out and see how it changes over time to see if some deployment changed it. We do see that there was some kind of a spike, so something changed probably. Let's see if we find some patterns. So it shows some common logs and their counts. And it does turn out that some of the errors occur more often. And here, this is to show that, like I mentioned, you're able to query and create alerts on logs. So you can directly take that log and create an alert on that. The last piece is you have that error. You don't know what it means. So we have the Copilot, which is trained on a lot of information, which includes Azure docs, which includes Kubernetes docs. So you're able to analyze that right here without having to go elsewhere right from portal. So it goes through all of that, and it gives you a recommendation of it is able to figure out and also point to some of the docs if you're interested to delve deeper. So it does show that you have this error and look at some of the extension deployment logs. Awesome. And this is most of this is there already today, so check it out and definitely let us know what you think. Next, I talked a little bit about diagnose and solve. What's next for diagnose and solve? What if I told you don't have to choose the category and go through it? You just state your error, and we will analyze all of it for you. So this is an exciting capability where, again, similar to some of the other ones, where we do all the heavy lifting and we analyze a lot of it for you and make sure that you don't have to go through all of this. It has some of the follow-up suggestions as well. So this is for if you want access to this, you should very soon see a banner asking for request access. We are looking for feedback on how it's working, whether it's actually addressing your use case. So definitely check it out and let us know. You also have a blog post about the announcement. Awesome. I'm also excited to announce that the Monitor OpenTelemetry distro is now GA. It's a wrapper on the OpenTelemetry library, and also the HTTP semantic conventions is now stable. At this point, I will call upon Neha to discuss and show a demo on some of the exciting networking capabilities.
Thank you, Aritra. Those were really some cool demos. But let's switch to what I hope is your favorite topic of the day, network observability. Network and observability, they go well together, right? Right? Hello, everyone. I am Neha Aggrawal. I'm a dev manager at Microsoft in Azure Networking, and I lead the network observability in Azure Kubernetes Service. So earlier today, in case you missed it, in Azure keynote, Deepak has announced an upcoming availability for Azure Advanced Networking Observability. So I'm going to be using that and the integrated Grafana dashboards to showcase a real-life scenario. Imagine we are an app developer, and my app is showing some intermittent blips, classic networking issue. So let me show you the power of advanced networking observability and solve this issue in 5 minutes, which otherwise would have taken an hour, maybe days, right? So let's debug. I need my laptop. So let's pray the demo gods. I'm going to be doing a live demo. Okay. As an application developer, the very first thing I would do is I'm going to just check my application telemetry. What is going on? Why I'm seeing some intermittent drops? So I'm already connected to the cluster. So let me just check my application name. And this is my application, the Contoso app, which is showing the drops. Okay. Is this good? Okay. So I'm going to check my application telemetry and see, am I seeing any anomaly here? Oh, yes. As the logs are showing, I'm seeing some DNS lookup failure. And I'm seeing I'm not able to reach out not able to resolve the Microsoft.com, and I'm getting some IO timeout. Till yesterday, we all know we may have to run some 30 more commands to debug this. But today, we have something new. We have Azure Managed Grafana, we have Advanced Networking Observability, and we have some really awesome dashboards. So let's switch. We saw it from the application. That application has some DNS issues. So let's switch to a deep dive insights into the DNS dashboard. Are you seeing any anomalies here? So on the right side, we started to see an uptick on the DNS missing response. So my core DNS is missing some request. And here, and I do see my request to the Microsoft.com has drastically reduced. So what's going on with my core DNS pod? I'll switch to different dashboard to see how my core DNS application is working. So here I'm onto the pod workload dashboard. So this dashboard talks about the workload level insights. So like workload, your deployment. So I'm going to switch to my core DNS workload and see how my core DNS pods are performing. OK, so this particular dash shows how my traffic distribution looks like across my instances of a core DNS pod. I do see that this particular instance, the ZN FKC, is not receiving as equal request as my other pod. So what's going on with this pod? Let's find out, further dig deep and find out, am I seeing any drops? Oh yeah, I am. In this instance, I'm seeing a lot of drops happening on a particular instance, but my other pod is working fine. So why is only one pod acting differently, the other pod? How about I switch to another dashboard, which is a cluster view, and see, is this happening something on the specific node where this core DNS pod is deployed? So I'm going to switch to another dash, which is a cluster level dash. At a cluster level dash, I do see there are some packets are getting dropped, and they're getting dropped only on a particular node. And I also have a reason of why they're getting dropped. They are getting dropped because of some IP table rule added. Oh my God, who added this IP table rule? Let's find out. Let's just get to the cluster and find out why my IP table rule is getting dropped. So I'm already connected inside my node. And I'm going to run the classic command. Okay. Let me just zoom it again. Is it visible? So yes, with my IP tables, I can see there is one particular rule which is showing a lot of drops. So this particular thing is what counts. Anytime a rule gets hit, you will see an uptick. If I run it again, you see this is getting an uptick. So, okay, what is this rule about? Yeah, this is my core DNS IP. Oh, it's added by my network admin. So as an application developer, I'm going to reach out to my network admin to find out, let's please fix this, my app. So this is about my demo. So plus, I also wanted to extend. Sometimes I was able to fix this issue using my integrated dashboards. Some of the times, my intermittent app does not have a live repro. And with the power of these historic metrics, I can go back in time and I can see all this, what we have seen it in a live demo. But sometimes I do have a live tracing and I would want to go further deep down and I want to also get the flow logs. As we announced earlier, we also have the capability of flow logging along with the metrics inside. You can also go inside your cluster, connect to your Hubble relay, and then also get all the coolness of Hubble observed flows and get the detail inside, and go even further down and debug the whole 5-tuple. Okay. And debug the whole 5-tuple data and go more insights of what's going on. So that's about my demo. Thank you. I'll give the stage back to Aritra.
Awesome. Hope you all enjoyed the demo and you're already seeing how the detect and diagnose pieces coming together and how we're able to diagnose much more effectively with some of the signals that we have. Oh, sorry, I think this is not. Awesome. Now we'll move on to the remediate phase, where essentially you're trying to address the issue so that it probably, hopefully, doesn't happen again. These are some of the best practices. First, some of you might be aware, we have a node auto repair, which auto heals nodes after a certain amount of time when we see that things they are not healthy. Definitely take a look at some of the Azure advisor recommendations. This has a lot of personalized actionable recommendations. Whenever possible, we would advise automating your remediation so that you don't have to manually do any of this. And only after you do the mitigation, then do the root cause analysis. And last but not the least, definitely check out the exclusive repo where we have some of the common troubleshooting AKS errors so that you don't have to go elsewhere. I'm excited to announce the public preview of the delete API for nodes. A lot of you have been asking for a way to automatically delete nodes. And note that the advantage of this is you don't have to look at the underlying compute. You can do it through the AKS API. And the advantage is specifically the fact that this follows the Kubernetes coordinate drain and deletes it from the API server itself. So you're well covered. This is specifically for customers who can't wait for our auto healing to probably take action. If you have very sensitive workloads, sometimes you may have hanging nodes where you quickly want to delete the node. Awesome. At this point, I'll hand it over to Pavneet to wrap up this session.
So I see some glazed eyes. I can hear some tummies grumbling. So I apologize. I'm the last person standing between you and lunch. I'm Pavneet Ahluwalia. I'm a principal PM for Azure Kubernetes Service. I focus on performance, scale, observability, and some of the AI features we're working on. And that's what I wanted to demo today. So the demo we're going to go through is basically somebody has deployed a rogue client in the cluster, which is making a lot of API calls. And that can be very problematic, especially when you're deploying some of the open source or third-party controllers, which are not always optimized for performance or scale. So how do you detect that, and what are the different tools that AKS provides you to detect and diagnose and remediate that? And then we're going to go into an AI-related feature that we're working on, which does a lot of the magic for you. So let's get started. We have a basic e-commerce pet supplies website here, which has two interfaces, one for the admins and one for the customer. And I'm going to jump into the AKS cluster to show what's running behind the scenes. So this is the AKS cluster on which this demo is running. It's 1.28.5 Kubernetes version that we're using. So please stay up to date on your Kubernetes versions. And on the workloads, the deployment is in the pet namespace. It has a bunch of microservices which is handling the orders, front end, etc. And then I'm going to show you the service which is giving the front end external IP on which customers are accessing the web portal. So that's deployed as a service here. That's the front storefront, and then there's the store admin, which both have their external IPs. So at this point, Aritra has called me and he's saying, hey, I'm trying to deploy some workloads and I'm seeing a lot of latency from API server. What's happening? Can you help me figure that out? So I'm going to jump into the CLI and see, okay, let me try it out. Let me run a basic, get pods across all namespaces to see, are we seeing latency? And we are. It is taking several seconds to get a response. So I'm going to try to figure out, okay, why is this happening? It's not a big cluster. It shouldn't be a scale issue. So what's happening here? And always, when I'm trying to diagnose an issue, I start with the diagnose and solve blade in the portal. So I go to that, and now I'm going to see a bunch of categories, right? Because I've not enabled in the Copilot AI features that Aritra showed. So I'm going to go myself to the cluster control plane availability and performance blade, which is going to run a bunch of predetermined detectors, things that we see often in clusters. We built detectors into AKS to kind of help you diagnose them on demand. And I'm seeing some throttling from Azure API, but that doesn't explain what's happening. So let me go check the etcd issue. Maybe it's an etcd issue, right? And everything checks out. There's no issue in the etcd. So what do I do now? The next step is I'll go to the events blade. That's where I go next to see, hey, is there anything popping out that might explain what's happening? So I'm going to the events blade, and it shows me all the events from the Kubernetes, right? I'm seeing a few warnings, but they seem to be memory issues on pods that are running. That also doesn't explain the latency I'm seeing. So let me see what are the diagnostic settings I've enabled on this cluster so that I can do a deeper dive. What I'm looking for is control plane logs. Do I have control plane logs enabled? And luckily, Aritra followed the best practices, and he does have control plane logs enabled. So I can see Kubernetes API server logs, I have audit logs, and I also have control plane metrics enabled on this cluster. So I'm going to jump into that and see what's happening with my API server metrics. So when you enable control plane metrics on AKS, you get a Grafana dashboard built in with your managed Prometheus and managed Grafana offering. So I'm going to switch over to that now. And there I have it. That's the default control plane metrics dashboard that you get with Azure managed Grafana. And I see there are a few in-flight requests, not too much, nothing to be worried about. But I'm seeing a lot of HTTP requests and a few failures, the 5xx failures that I'm seeing. And the latency is not very high, but it's higher than normal, right? 300 milliseconds, slightly higher than what I would expect for a cluster this size. And I do see there are a lot of list calls happening. On the top right corner, I see a lot of list calls, 2,000 list calls on average happening every minute. That's pretty high when I'm not running a lot of things in my cluster. So I want to know which user agent is making those calls, so that I can detect that and figure out what's wrong with that application. Why is it calling the API server so much? And for that, I'm going to jump into my logs analytics workspace. And earlier, Aritra had showed how you can use Copilot to build some of your KQL queries for you. Unfortunately, I'm not opted into that private preview, so I'm going to write those queries myself. So you have some built-in queries. I'm going to start there. So first, I'm looking at the calls that are being made by IP address. And I see that there's that one particular IP address which is making thousands of calls, list calls specifically. So I go to the troubleshooting docs. There's a troubleshooting doc for API server and etcd issues. And I'm going to pick up this query which tells you by user agent the count of calls to the API server. And that will tell me exactly who's the culprit here. So I copy that over to my log analytics workspace. I run the query. And there it is. Oh, no, it's not. The person has not configured user agent into their client properly. So I know somebody is making a lot of those calls, but I don't know who. So I'm going to try something different. I'm going to look at the calls by service account. Right? Somebody has to be authenticating with the API server with the service account. Maybe I can look at a query for that. And there it is. I'm going to run the query. And at last, I have my answer. There's an application in the default namespace which is using a work pressure service account, which is making all these calls. Now I can go over, look at that workload, and actually ask whichever developer deployed it to see why are you making so many list calls. So AKS has given me all the tools to diagnose, to detect, and to figure out where is the issue coming from. But what if I told you, you don't have to go through all these 6, 7 steps that I just went through? What if AKS was automatically detecting issues in your cluster, diagnosing them proactively, and then doing the remediation actions for you? Once you enable that feature, it will automatically do all those steps for you. And that's the feature I want to talk about next, AKS auto healing. It is something that is very early in development. We are still adding more use cases to it and trying to test it and make it holistic. But I wanted to give you a sneak peek about it today. And coincidentally, the idea for this feature was born in the previous KubeCon with some of the discussions with our customers here. So let's jump into it. I have a different cluster which I've deployed, which has the same set of applications. In the pets namespace, I'm running the same e-commerce website. And then I have in the default namespace the same work pressure application, which is making a lot of list calls. So I'm going to invoke, before I'm going to show you what I'm running. I'm running a service called AKS Auto Healing in the control plane. And that's the service endpoint that I'm invoking at this point. And I'm saying detect API server issues. Now, in the final experience that you'll see, you won't even need to do this. This will automatically run in the background and constantly look for issues in your cluster. But since this is a POC demo, I'm kind of showing you the under the hood details of how it works. So I've invoked that endpoint, and now it's doing the analytics for me. And it's detected that there's a service account in the default namespace called work pressure, which is making list calls for pods across all namespaces. And it gives me that information in an easy-to-digest way. But wait, it has also created the priority and fairness flow schema and the priority configuration for me so that now it is automatically throttling that aggressive client that we saw earlier. So you don't need to do anything. AKS automatically detected, diagnosed, and mitigated the issue for you. Now, let me just show you that this is not a fake. It did actually deploy the configs that we're talking about. So I'm just going to do a get flow schema on that cluster. I'm switching back to the cluster where it deployed in. And there it is, the auto healing flow schema that it has created and automatically deployed to throttle that client. And then I'll also do the kubectl get priority configuration to show you the priority configuration that it created for you. So there it is, AKS auto healing. That's an internal name. The name might change by the time it goes preview. But the goal is to proactively detect, diagnose, and remediate issues for you once you've enabled that feature in your cluster. Thank you. And we showed you a bunch of QR codes for preview features and feedback. Please feel free to scan them now or take a picture of the slide to use later. And we love your feedback. Please provide it to us so that we can keep innovating on your behalf and make your life easier with AKS. Thank you.